Imagine looking up at the night sky, the same sky that has carried the dreams and fears of humanity for thousands of years, and realizing that something has just slipped into our solar system, fast, silent, and utterly unwilling to stop. It does not announce its arrival with fire or thunder. It does not come trailing the familiar shimmer of a comet's icy tail. It is simply there, a faint speck moving in ways that feel strangely alien, brushing past our cosmic neighborhood with a kind of cold indifference. And in that moment, astronomers, the patient guardians of the night, realized they were witnessing something extraordinary. The cosmos has always carried with it a rhythm, a sense of order. Planets circle their stars with almost clockwork precision, moons obey the pull of gravity, and comets announce themselves in glowing arcs of vapor and dust. For generations, scientists believed they understood the family portrait of our solar system, every object bound by the familiar tether of the sun's gravity. Yet every so often, the universe reminds us that it is not quiet, not predictable, and certainly not finished with its surprises. In the year 2017, that reminder came in the form of a faint glimmer captured by telescopes in Hawaii. What they saw was unlike any asteroid, comet, or planet that had ever been cataloged. At first, it seemed like another routine discovery, just a dot of light drifting against the darker sea of stars. But as more data arrived, the pattern revealed itself. This object was moving far too quickly, following a trajectory that ignored the circular dance of our planets. It had not been born here. It did not belong here. They named it Oumuamua, a word chosen with care and reverence. In Hawaiian, it means scout or messenger, a fitting title for something that had journeyed across unimaginable distances before brushing against us. The name carried with it a sense of watchfulness, as if this traveler had been sent ahead from some unknown origin to pass through our skies and remind us how wide the universe really is. Oumuamua was not like the comets we know, those icy wanderers that fall inward from the edges of our system, burning their essence away as they near the sun. Nor was it like an asteroid, those rocky fragments bound by gravity to our sun's eternal pull. No, this was different. Its path was not closed, not curved into the familiar ellipse of orbit. Instead, it was open-ended, a hyperbolic arc cutting across the solar system with the clear intent of leaving again. To imagine it properly, one might think of a ship passing through a harbor without ever lowering its anchor. It did not come to stay, only to pass through, silent and remote, as though the sun was just another star in its long journey. Astronomers, who so often search for the comforting patterns of motion, found themselves staring at something that bent the rules of what they thought was possible. It was as if the universe had suddenly dropped a riddle into their hands, one whose answer lay beyond the familiar boundaries of their textbooks. For the first time in human history, here was proof that fragments from other star systems could reach us, that interstellar messengers were real. Oumuamua was not bound to the family of planets and comets that circle our sun. It was a foreigner, a piece of some distant system, carrying with it the history of another star, another home we may never know. The very fact of its presence whispered something profound. Our solar system is not isolated. We are not a lone island floating in emptiness. We are part of a greater current, a galaxy alive with exchange, where matter drifts between stars like messages in a bottle across a cosmic ocean. The impact of this realization is hard to overstate. For centuries, astronomers had speculated that such interstellar travelers might exist. But speculation is not proof. The night sky is full of mysteries, but rarely does one pass so close, leaving its mark in the data and in the imagination all at once. Oumuamua forced scientists, and by extension all of us, to widen the frame of our thinking. It was not enough to understand comets, asteroids, or planets as closed systems bound by the sun's gravity. Suddenly, the solar system was revealed as porous, open to visitors from the wider galaxy. And if one had come, how many more might have slipped by unnoticed before our instruments were sharp enough to see? Take a moment to think about this. Here was an object that had likely wandered the galaxy for millions, perhaps billions of years before arriving at our doorstep. In its tumbling, silent motion, it carried the memory of another world, another star's birth and death, another system's story, written in the quiet language of stone and dust. And yet, it brushed past us almost casually, like a stranger passing by on a crowded street, leaving only questions in its wake. What does it mean, then, to witness such a thing? On one level, it is a triumph of astronomy, a confirmation of theories long held. On another, it is a deeply unsettling reminder of our place in the cosmos. If fragments can travel so far, if messengers like Oumuamua drift between stars, then our own solar system too must be shedding pieces of itself, flinging dust and stone outward to journey into the darkness. Perhaps even now, fragments of Earth and Mars are moving silently toward distant suns, destined to pass unseen across alien skies. Oumuamua, in this light, becomes not just an object of scientific curiosity, but a mirror. In its motion, we glimpse ourselves. We too are travelers, bound to a fragile planet circling a medium-sized star, moving together through a galaxy vast beyond measure. When we look at Oumuamua, we are not just looking at a piece of foreign rock, but at the truth of existence itself. That nothing stands still, that everything moves, that the universe is alive with exchange. And yet, as profound as this realization was, it carried with it a deeper question. If it was not a comet, not an asteroid, then what was it? The name Scout suggests intention, and though that may simply be poetic, it lingers in the imagination. Was this a shard of a shattered planet, a relic of cosmic violence, cast adrift until chance carried it to us? Or was it something more unusual, something beyond the natural categories we know? Astronomers debated, measured, and speculated, but the truth remained elusive. Oumuamua was faint, fast, and frustratingly unwilling to be studied in depth. Within weeks, it had already passed too far, too dim for our telescopes to observe. We were left with only fragments of data, enough to confirm its mystery, but not enough to solve it. And so, like any good riddle, it left us hanging, leaning forward in curiosity. This was only the beginning, a doorway into deeper questions, stranger theories, and unsettling possibilities. For if Oumuamua was not a comet and not an asteroid, then what exactly had just passed through our solar system without slowing down? When astronomers first began piecing together the details of Oumuamua, they expected to find something familiar. After all, space rocks are generally predictable. They are lumpy, uneven, a little battered by time and cosmic collisions. They are potato-shaped, spheroidal, or jagged, depending on how they were born and what they endured. But what emerged from the early measurements of this strange visitor was nothing of the sort. Oumuamua, it seemed, was stretched. Not just a little, but bizarrely so. Some estimates suggested it was perhaps 10 times longer than it was wide, a cosmic spindle twisting silently in the dark. Others argued it could be thin, almost flat, like a pancake or a disc tumbling end over end. Its exact proportions were maddeningly uncertain because it was so faint and so distant. Yet the one thing scientists agreed upon was that it did not resemble anything they had ever seen before in our solar system. Imagine the contrast. Most asteroids in our neighborhood are squat and irregular, their shapes the result of countless impacts over billions of years. Comets, too, have familiar profiles, often bulbous cores surrounded by ghostly tails. Oumuamua, on the other hand, seemed unnervingly sleek. Its dimensions called to mind manufactured objects, elongated ships from the pages of science fiction, or tools carved deliberately for travel. It was as though the universe had handed us a shape that simply should not exist if it were only the product of natural forces. The problem was compounded by how the object reflected light. Oumuamua's brightness fluctuated dramatically as it spun, suggesting that it was rotating in an uneven, tumbling motion. This gave astronomers their best clues to its form, because each dip and surge in brightness hinted at the proportions of its surface. The data implied a body far more elongated than any asteroid or comet ever recorded, a cosmic cigar, a thin shard, or perhaps, if viewed from another angle, a wide, flat disk, skimming like a stone across the emptiness. Such shapes presented puzzles. How could something so extreme survive the brutal conditions of interstellar space? A cigar-shaped body might be fragile, prone to breaking apart under stress. A flat, pancake-like form seemed equally implausible for a rock adrift in the galaxy. Natural objects are usually rounded, compact, designed by gravity itself to minimize weakness. Yet, here was an exception, an interstellar enigma, that defied the logic of geology and celestial mechanics. Some scientists suggested it might be a shard from a larger body, a fragment torn free during the violent birth of a star system. If a planet had once been shredded by gravity, flung apart by the tides of its sun, or by a catastrophic collision, a sliver of its crust could have been launched into interstellar exile. Over eons, battered by radiation and cosmic dust, it might have weathered into the strange, elongated form now spinning through our skies. This explanation held a certain poetic appeal, a reminder that our galaxy is littered with the debris of ancient violence. Yet even this did not quite satisfy. The degree of elongation still seemed extreme, more than nature usually allows. Some wondered if it was less like a rock and more like a splinter, a piece of something once greater, fractured and flung outward. The possibility lingered that Oumuamua was not simply a natural shard, but perhaps something engineered. A structure crafted by intelligence, though to what purpose, no one could say. This is where the mind resists and imagination takes over. Humanity has long dreamed of visitors from the stars, of alien probes sweeping silently into our solar system. Science fiction has been filled with such imagery for decades, and here was an object whose shape seemed to echo those very imaginings. The line between coincidence and suggestion grew thin. Was the resemblance only in our minds, a trick of projection? Or was Oumuamua's shape truly a sign that it did not come into being by accident? Astronomers debated fiercely. Some insisted that invoking alien technology was reckless, an abandonment of scientific discipline. Others argued that the oddity of the object demanded bold hypotheses. After all, if science is the pursuit of truth, then it must also be the pursuit of possibilities, even the ones that feel uncomfortable. Beyond the scientific disputes lay deeper implications. If Oumuamua were natural, it would still be one of the strangest messengers we had ever encountered, a piece of another world so unusual it defied our categories. If it were artificial, then it was something else entirely. A deliberate construction passing through our skies, perhaps built by minds long gone, perhaps drifting without purpose, or perhaps still serving a function we could not yet comprehend. In either case, the message was clear. The universe holds more diversity, more imagination, more possibility than we have yet dared to expect. The human response to its shape was not purely scientific, but also emotional. There was awe, and there was unease. To stare at a form that does not belong, a geometry alien to the patterns of our solar system, is to confront the unfamiliar in its purest form. We are wired to find meaning in shapes, to connect them to intentions. When we see a line where there should be a curve, when we see sharpness where we expect roundness, our minds whisper that something unusual is at play, something intentional, something crafted. Perhaps this is why Oumuamua stirred so much imagination in the public. It was not merely that it was fast or foreign. It was that its very shape felt like a challenge, a cosmic riddle. Nature, after all, tends toward patterns we recognize, but this object resisted those patterns. It was as though the universe had sketched something new onto the canvas of our imagination, a form we had not rehearsed for, one that did not fit neatly into the categories we thought complete. And so astronomers were left with their endless questions. Was it a shard from a shattered world? A piece of a distant planet's crust, worn into strangeness by its long journey? Or, whispered more softly, was it an artifact, a relic of a civilization not our own, still drifting after countless ages of silence? No answer satisfied entirely, and no theory erased the mystery. As scientists studied the tumbling light of Oumuamua, their equations pointing in circles, a new puzzle emerged, one even stranger than its shape. For while its geometry raised eyebrows and stretched imaginations, its motion carried a clue far more unsettling. The object was not just unusual in form, it was unusual in movement. Something about its path betrayed an energy beyond gravity, as though it carried with it a secret engine, an invisible push from nowhere at all. And that was when astronomers realized the mystery had deepened. Oumuamua was not merely oddly shaped, it was accelerating. When astronomers track the movements of objects in space, there is a comforting predictability to it all. The dance of celestial mechanics has been charted for centuries, its rules written in the equations of gravity. A comet arcs toward the sun, speeds up as it falls inward, then slows again as it climbs back into the outer dark. An asteroid circles in a steady ellipse, pulled endlessly into its familiar loop. Planets and moons, stars and galaxies all bend to the same invisible law. It is the one rule the cosmos has always obeyed, the constant by which navigators, scientists, and dreamers have charted their way through the heavens. But in 2017, the arrival of Oumuamua showed us what happens when something refuses to play by those rules. For as astronomers carefully traced its path, measuring its position night after night, a subtle deviation emerged. At first, it was almost imperceptible, a tiny nudge that seemed like an error in the data. Yet the more they refined their calculations, the clearer it became. After swinging past the sun, Oumuamua was moving slightly faster than gravity alone could explain. It was as though an invisible hand had reached out and pushed it, a faint but undeniable acceleration that carried it more swiftly away from the star's pull. And in the language of science, such an anomaly is never ignored. It demands explanation, for if even one rock refuses to obey gravity, then our understanding of the universe may be incomplete. The obvious culprit was familiar to anyone who studies comets. When a comet nears the sun, its icy surface begins to sublimate, vaporizing into gas that streams outward into space. This outgassing acts like a rocket engine, producing tiny jets of thrust that can alter the comet's motion. Astronomers have long accounted for this effect, and it neatly explains the wandering paths of icy visitors from the Kuiper Belt and Oort cloud. But here was the problem. Oumuamua showed no tail, no plume of gas, no shimmering coma of dust. It was as dry and barren as an asteroid, its surface betraying no signs of sublimating ice. If outgassing was the explanation, then why had no one seen its evidence? Sensitive instruments scanned it for any trace of activity, but the object remained frustratingly clean, as though carved from something far more stubborn than ice. And so the riddle deepened. What invisible mechanism had given Oumuamua its push? If it was not a comet, then why did it behave like one? One theory was that sunlight itself might have been enough. Photons, the tiny packets of light, carry with them a whisper of momentum. Over time, this gentle pressure can push on surfaces, much like a steady wind moves a sail. The idea suggested that if Oumuamua were unusually thin, like a sheet or a fragment of cosmic foil, then sunlight could have nudged it along, producing the acceleration observed. It would mean the object was not dense and rocky like an asteroid, but delicate, perhaps only millimeters thick. This possibility sparked imaginations, because humanity has already dreamed of building such things. A light sail, powered only by starlight, could one day carry human-made probes across interstellar space. Could Oumuamua have been something similar, not crafted by us, but by others, perhaps long ago? Or was it simply nature's own experiment, a wafer-thin shard that happened to resemble the technology we ourselves aspire to create? Others cautioned against leaping too quickly to extraordinary conclusions. They searched for subtler explanations. Perhaps Oumuamua was made of exotic ices that sublimated in ways invisible to our instruments, releasing gas without producing the familiar tails of comets. Or perhaps its surface was covered in dust that masked any evidence of activity. Some suggested that fragments of hydrogen ice, almost impossible to detect, could evaporate quietly, leaving only the faintest traces. Yet each of these hypotheses carried its own challenges, and none fully satisfied the puzzle. What was left was not an answer, but a deepening of the mystery. For in astronomy, when the familiar rules do not apply, imagination must fill the gaps. Scientists, usually so careful with their words, found themselves speaking in possibilities rather than certainties. Was Oumuamua natural, or was it something more? Was it a shard of ice sculpted by forces we barely understand, or was it a sail, a messenger, perhaps even a relic of intention? The emotional weight of the question was as heavy as the science. To admit that an object might have been accelerated by starlight alone was to flirt with the boundary of technology and biology beyond our own. To consider that it might hide a mechanism we could not detect was to imagine intelligence beyond Earth. But to fall back on natural explanations, however unsatisfying, was to protect the comfort of science from wandering too far into speculation. Take a moment to consider the subtlety of it all. This was no blazing starship streaking across the heavens. no unmistakable beacon of alien design. It was a faint rock, so small and dim that most telescopes barely glimpsed it. And yet, hidden in the details of its motion, in the faint acceleration it carried as it left our sun behind, lay the seed of the extraordinary. Sometimes, the most profound mysteries are not shouted but whispered. In a sense, this non-gravitational acceleration was a gift. It transformed Oumuamua from a curious oddity into a cosmic riddle, one that forces us to confront the limits of our understanding. It reminds us that science is not about answers, but about questions that deepen the more we explore them. And it places us in a position both humbling and exhilarating, caught between the comfort of known physics and the tantalizing edge of the unknown. The push that came from nowhere lingers in our minds because it resists resolution. If it was sunlight, then Oumuamua was unlike any other rock we have known. If it was outgassing, then it was the strangest comet in history. And if it was neither, then perhaps it was something entirely new, a phenomenon we have yet to name, or an artifact whose purpose we cannot yet guess. And so the mystery grew. Astronomers continued to debate, to calculate, to argue across conferences and papers. The object itself receded into the distance, too faint to follow, leaving behind only numbers and possibilities. Yet the questions it raised remain with us still, echoing in the quiet halls of science and in the restless corners of imagination. That single, subtle acceleration, almost too small to notice, cracked open a floodgate of theories. It invited us to imagine worlds beyond our own, civilizations unknown, or physics not yet discovered. And once that door has been opened, it cannot easily be closed. Science thrives on questions, yet it also thrives on restraint. For every bold idea that pushes against the boundaries of knowledge, there are countless careful voices urging caution. In 2017, when Oumuamua brushed past our sun and left astronomers puzzled by its strange shape and inexplicable acceleration, most researchers clung to familiar explanations. Exotic ices, hidden jets of gas, fragments from shattered worlds. These were the safer answers, the ones that did not disturb the fragile line between science and speculation. And yet, there was one scientist who chose not to stay within the bounds of caution. One voice that dared to put into words what many had only whispered, sometimes only in private. That voice belonged to Avi Loeb, a professor at Harvard University, a respected astrophysicist known both for his deep insights and for his willingness to take intellectual risks. Loeb asked the question that many secretly feared. What if Oumuamua was not natural at all? What if it was artificial? The suggestion carried with it an electric weight. To call something artificial is to call it a product of design, a creation of intelligence. And since Oumuamua was not built by us, that intelligence would have to belong to someone or something else. Loeb did not claim certainty, but he did propose a provocative possibility. Perhaps Oumuamua was a light sail, a thin sheet crafted to travel through space using nothing but starlight as its engine. The concept of a light sail is not science fiction. Humanity itself has toyed with the idea for decades. The principle is disarmingly simple. Light, though intangible, carries momentum. When photons strike a surface, they impart a minuscule push, like the faint pressure of wind against a sail. Over time, with a large enough surface and enough light, this pressure can accelerate an object across space without the need for fuel. It is an elegant solution to one of space travel's oldest dilemmas: how to move without carrying the heavy burden of propellant. Projects on Earth, such as the Japanese Space Agency's Icaros mission, have already unfurled sails in space, proving the idea works. More ambitious plans, like Breakthrough Starshot, dream of sending tiny probes across interstellar distances, driven by powerful beams of light. Humanity, in other words, has already imagined and begun to build the very technology that Loeb suggested Oumuamua might represent. Could another civilization, far older and more advanced, have perfected it long ago? Could Oumuamua have been their craft, silently drifting, powered by the sun's light as it passed through our neighborhood? The shape seemed to fit the idea. Its thinness, its elongation, its strange acceleration, all were consistent with a sail catching starlight. To entertain this possibility was to place Oumuamua not in the category of comet or asteroid, but in the category of artifact. The reaction to Loeb's hypothesis was as divided as it was intense. Some hailed it as bold, a reminder that science should not shy away from extraordinary explanations when extraordinary evidence arises. Others dismissed it as reckless, a leap too far into the territory of speculation. They warned that invoking aliens without proof risked undermining the credibility of astronomy, that it might feed the fires of sensationalism rather than illuminate the truth. But the unsettling truth was this: no one could prove him wrong. Every natural explanation carried its own shortcomings. Every attempt to fit Oumuamua into the familiar categories left gaps unfilled. The object had already slipped away, too faint to study further, leaving behind only questions and possibilities. In that vacuum of certainty, Loeb's suggestion held a kind of stubborn presence. It could not be confirmed, but it could not be dismissed either. What made the idea so powerful was not only its content, but its implications. If Oumuamua were artificial, then it was evidence of something profound. We are not alone. Somewhere out there, another civilization had once built, once launched, and once set adrift a creation that had wandered through the galaxy until it brushed past us. Whether it was active or long dead, whether it was intentional or accidental, it would stand as proof that intelligence was not unique to Earth. Take a moment to imagine the weight of that. The night sky, which for so long has seemed silent and indifferent, might instead be filled with echoes of other minds, other stories, other journeys. If a single fragment of technology had reached us, then how many others might be drifting unseen, silent witnesses to civilizations scattered across the galaxy? And if we ourselves have already sent probes like Voyager and Pioneer into interstellar space, might we not expect that others have done the same, their creations wandering until they cross paths with distant suns? The philosophical shock of Loeb's hypothesis was as deep as the scientific one. For centuries, humanity has asked whether we are alone. The possibility that Oumuamua was artificial did not answer the question fully, but it forced us to face it with new urgency. If the galaxy is alive with technology, then our place within it is not as solitary as we once believed. If we are not alone, then everything from our religions to our sciences, from our fears to our hopes, must expand to accommodate that truth. Of course, the counter-arguments remain strong. Skeptics point out that extraordinary claims require extraordinary evidence, and Oumuamua left us with precious little. A faint light curve, a puzzling trajectory, an unexplained acceleration. These are hardly enough to rewrite the story of humanity's place in the cosmos. And yet, perhaps the point is not that Loeb's hypothesis is right, but that it cannot be so easily ruled out. Science is not about closing doors, but about leaving them open until the evidence compels us otherwise. In the years since, Loeb has doubled down on his conviction, publishing books and essays that argue for a new openness in scientific inquiry. He insists that dismissing the possibility of extraterrestrial technology is itself unscientific, a failure of imagination disguised as caution. Whether one agrees or not, his words have stirred a conversation that lingers, a reminder that the universe is larger than our certainties, and that sometimes the boldest questions are the ones worth asking. And perhaps this is where the true meaning of Oumuamua lies. Not in whether it was a rock or a sail, natural or artificial, but in the way it forces us to stretch our imagination. To live with the unknown is to live with humility, to admit that the universe has not finished surprising us. Whether shard of stone or relic of design, Oumuamua was a messenger, one that arrived not with answers, but with questions. And those questions, whispered into our skies, may be the most valuable gift it left behind. The debate over Loeb's idea continues, unresolved, alive with tension between skepticism and wonder. Perhaps future visitors will settle it for us. Perhaps one day another object will appear, closer, clearer, bearing evidence undeniable. Until then, we live in the space between possibility and proof, suspended in the delicate balance of science and imagination. And Oumuamua, that silent traveler, is gone, already lost to the dark, leaving only the memory of its passing. Yet even as it vanishes into the void, the door it opened remains wide, a threshold to new ways of seeing the universe. And this was not the only strange visitor to wander through our cosmic home. For a time, Oumuamua seemed like a solitary enigma, a one-of-a-kind visitor whose mystery would never repeat. Astronomers whispered that perhaps it was a cosmic accident, a fleeting event, unlikely to ever grace us again in their lifetimes. The odds of catching one interstellar object had seemed almost impossibly small. Surely the cosmos would not send us another so soon. And yet, in the late months of 2019, just 2 years after Oumuamua had slipped beyond reach, the sky offered up a second revelation. This time, the discoverer was not a massive observatory, but a lone amateur astronomer, peering at the heavens through his modest telescope. His name was Gennady Borisov, and on a clear night in Crimea, he noticed something unusual, something faint but insistent, a smudge of light that did not belong to the catalogs of stars or comets. He tracked it carefully, shared his findings, and soon the global community of astronomers confirmed the astonishing truth. Borisov had found the second interstellar visitor, an object that came not from our solar system, but from the deep reaches of the galactic sea. It was officially named 2I Borisov, the 2I, standing for Second Interstellar, a quiet acknowledgement that humanity was now living in a new chapter of cosmic history. For centuries, we had speculated about objects drifting between the stars, but now we had met 2 of them, back to back, like whispers arriving one after another at our cosmic doorstep. What had seemed like a once-in-a-lifetime anomaly was instead becoming a pattern, a hint that the galaxy might be more permeable, more interconnected than we had dared imagine. Unlike Oumuamua, whose strange shape and unexplained acceleration had sown confusion, Borisov seemed, at first glance, more familiar. Through telescopes, it revealed the signature glow of a coma, that hazy envelope of gas and dust that forms when a comet approaches a star and begins to sublimate. Its tail stretched into the void, a banner of evaporation, a classic sign of icy material meeting the warmth of sunlight. In its behavior, Borisov was much easier to understand, much easier to classify. It was, by all appearances, a comet. And yet, it was not an ordinary comet. Its very existence carried within it a revelation. The gases it released, the dust it shed, the fingerprints of its chemistry, all spoke of a birthplace far from our sun, of a cradle among different stars. Borisov had been formed in a distant solar system, sculpted by alien forces, and then ejected into the endless night. It had traveled perhaps for millions, even billions of years, wandering between the stars until chance and gravity carried it into ours. In its nucleus, frozen deep within, lay the memory of its home system, the trace of conditions utterly unlike those of Earth. Astronomers analyzed its light with hungry eyes, eager to compare its chemistry to the comets we know so well. What they found was both comforting and humbling. In many ways, Borisov resembled the icy wanderers of our own solar system, its materials familiar, its behavior predictable. But there were subtle differences too, tiny signatures in its gas that hinted at variations in its origin. The story it carried was not entirely foreign, but neither was it identical. It was like meeting a distant cousin from a land long separated, whose language carried echoes of your own, but whose accent and words were shaped by another world. For scientists, Borisov's arrival confirmed something profound. Oumuamua might have been strange, perhaps even anomalous, but Borisov proved that interstellar objects were real and repeatable. The solar system, once imagined as an isolated bubble, was revealed instead as a crossroads. Objects from distant stars could and would continue to pass through, messengers of other realms, reminders that we live not on an island, but on a shoreline, with the galactic tide washing up treasures and mysteries from beyond. Take a moment to let that realization sink in. For most of human history, the stars were distant lights, unreachable, eternal, fixed in the vault of heaven. The planets and comets of our own system seemed like the totality of the cosmos we could touch. And yet here in our own lifetime, we have seen visitors arrive from other stars, carrying within them the raw material of alien worlds. The universe is not a stage set at a distance. It is a living web, its strands crossing and weaving, bringing fragments of elsewhere into our presence. The philosophical implications are as dizzying as the scientific ones. If comets like Borisov travel freely between systems, then the ingredients of life, the frozen water, the organic molecules, the dust, might not be bound to any one star. They might wander, carried from cradle to cradle, seeding possibilities across the galaxy. The panspermia hypothesis, once considered fringe, gains strength in the light of such messengers. Perhaps life itself is not a lonely spark, but a fire carried on the wind between stars. And even if Borisov carried no living seed, it carried meaning. It showed us that our neighborhood is porous, that we are not sealed away from the rest of the galaxy. There is traffic on the interstellar highways, traffic we are only just beginning to detect. The distances are immense, the encounters rare, but they are real, and each one is a reminder that we belong to something larger, something that stretches across the Milky Way. In the quiet glow of Borisov's tale, humanity could glimpse both comfort and unease. Comfort, because it suggested that the universe follows patterns, that our comets and theirs are kin, shaped by the same physics, the same chemistry. Unease, because it underscored just how vulnerable we are to the vastness beyond, how easily the foreign can enter our space, unannounced, unstoppable. And here, inevitably, the shadow of Oumuamua returned. If Borisov was natural, if it fit within the family of comets, then what of its predecessor, the elongated, silent traveler that refused to behave? The contrast between the two sharpened the mystery. Borisov was a comet, yes, but Oumuamua remained undefined, elusive, resistant to classification. Borisov confirmed that interstellar visitors are real, but it also deepened the question of what exactly the first visitor had been. The universe had spoken twice, in two different voices, in two different tones. One voice was familiar, echoing the icy comets of our youth. The other was strange, unsettling, unwilling to explain itself. Together, they whispered a message that was both thrilling and terrifying. We are not alone in the flow of cosmic traffic. The galaxy does not leave us untouched. Objects will continue to come, bringing their secrets, their riddles, their warnings. And so, as Borisov drifted back into the darkness, its tail fading like the smoke of a candle, astronomers were left with gratitude and unease. Gratitude for the chance to see another messenger. Unease because the first messenger had not been so easily explained. What if Oumuamua wasn't just another natural visitor? In science, there is a quiet rule, one rarely spoken aloud but deeply felt. The universe must make sense. It may be vast, it may be cold, it may be stranger than our imaginations, but beneath all its mysteries, the cosmos is expected to follow laws. Gravity pulls, light travels, matter obeys, and though the details may be complex, the patterns are meant to be discoverable. But what happens when something does not fit? What happens when the universe presents us with a phenomenon that seems to obey physics, yet in a way that does not add up? That is the puzzle Oumuamua left behind. From the moment astronomers tracked its path across the sky, they noticed peculiarities. Oumuamua was not gliding smoothly or spinning like a simple baton. Instead, it was tumbling chaotically, as though it had been thrown into the void with an awkward twist. This tumbling was not random, but it also did not align with any predictable model of how comets or asteroids spin. Its light flickered in strange patterns, brightening and dimming in a rhythm that suggested not only rotation, but a complex, uneven surface reflecting sunlight in surprising ways. Some scientists compared it to a shard of broken glass, spinning as it falls, each face catching the light in a brief, sharp gleam. Others imagined a cosmic shard of metal, bent and battered, flashing like a signal mirror in the void. Whatever it was, the data resisted the tidy categories astronomers preferred. It was not spherical, not potato-shaped, not like the icy boulders that wander through our solar system. It was something else. The very idea of something else carries with it a weight of unease. For centuries, astronomy has relied on classification, the sorting of objects into neat bins: stars, planets, moons, comets, asteroids. Each category tells a story. Each label gives us a sense of control. Oumuamua unsettled that order. It bent the light curves, defied the shapes, resisted the bins. It reminded us that nature does not owe us simplicity, and that the universe is under no obligation to fit inside our definitions. Take a moment to think about this. When we say the laws of physics, we mean patterns we have discovered, descriptions that work for everything we have observed so far. But the universe is older than us, stranger than us, larger than our instruments can measure. Every law we know is provisional, waiting for the anomaly that might bend it, reshape it, or reveal its incompleteness. Oumuamua, tumbling in its awkward dance, was one such anomaly. It was not breaking the laws of physics. Gravity still pulled on it, sunlight still struck it, momentum still carried it along its path. But the details, the way it spun, the way it accelerated, the way it reflected, hinted at a layer of complexity we had not yet grasped. It was as if physics was whispering back to us, saying, "You understand much, but not all." Throughout history, anomalies have been the seeds of revolution. The strange orbit of Mercury once defied Newton's predictions until Einstein's theory of relativity revealed the hidden curvature of spacetime. The unexpected spectrum of starlight, once puzzling, became the fingerprint of atoms, teaching us the very structure of matter. Again and again, the universe has placed before us puzzles that seemed impossible, only to reveal, in time, a deeper truth. Oumuamua might one day be remembered in the same way. Not as a curiosity, but as a messenger of physics not yet fully known. Perhaps it was shaped by forces in its home system that we cannot yet imagine. Perhaps it was sculpted by collisions or processes unique to alien worlds. Or perhaps it hinted at something entirely outside our present framework, waiting for future generations to uncover. There is humility in facing such mysteries. To admit that we do not yet understand is not failure. It is the essence of science. It is the reminder that knowledge is a horizon, and that each step forward only reveals how much farther there is to go. Oumuamua's odd tumbling, its uneven reflections, its refusal to conform, was not a rejection of physics. It was an invitation to deepen our understanding of it. And yet, anomalies also carry a more unsettling power. They blur the line between science and imagination. When an object behaves in ways that no current model can explain, the mind begins to wander into the spaces between. Could it be artificial? Could it be intentional? Could it be something we have no words for yet? That is the risk of anomalies. They open the door not only to new science, but to speculation. In this way, Oumuamua was both a gift and a challenge. It gave us data that stretched the edges of our understanding, but it also asked us to sit with discomfort, to resist the temptation of easy answers. For some, that discomfort was exhilarating. For others, it was troubling. But for all, it was unforgettable. The laws of physics remain intact, but our grasp of them is never complete. Oumuamua's impossible physics was not a contradiction. It was a reminder. The cosmos is not here to reassure us. It is here to astonish us, to puzzle us, to remind us that the unknown is not a void, but a frontier. And sometimes, when we stare into that frontier, the strangest possibilities echo not from the stars, but from our own imaginations. For centuries, human beings have looked to the stars and woven stories out of their mystery. When the night sky stretches overhead, endless and silent, imagination rushes to fill the void. We tell ourselves tales of other worlds, other beings, other travelers who might someday drift into our neighborhood. In that sense, science fiction has always been more than entertainment. It has been rehearsal, a way for our minds to prepare for the moment when imagination and reality finally collide. Few writers captured this rehearsal more powerfully than Arthur C. Clarke. In 1973, he published a novel called Rendezvous with Rama. The story begins with a familiar tension. Astronomers detect an object hurtling into the solar system, something vast and elongated, tumbling through space. At first, they assume it is just another asteroid, but as the evidence grows, it becomes clear this is no natural rock. It is a spacecraft, an immense hollow cylinder built by an intelligence far beyond our own. In Clarke's tale, humanity sends explorers to meet the visitor, to step inside its cavernous interior and discover its secrets. The vessel is quiet, seemingly dormant, and the explorers must grapple with the awe of realizing they stand within an artifact of an alien civilization. The novel is not about battles or invasions, but about mystery itself, the haunting, almost spiritual experience of encountering something crafted by another intelligence and not knowing its purpose. Now pause for a moment and remember Oumuamua, a long, elongated object, tumbling as it passed through the solar system, unlike any comet or asteroid ever seen, a visitor from the stars that refused to fit the molds we had built. The parallels are uncanny. Clarke's fiction seemed to ripple into fact, as though the universe had reached into our collective imagination and drawn forth one of our stories into the theater of reality. For many who followed the news in 2017, the comparison was irresistible. Headlines invoked Clarke's novel, reminding us that science fiction had already prepared our minds for the possibility of just such an encounter. Scientists, journalists, and readers alike whispered that eerie phrase, "Life imitates art." And this, perhaps, is one of the strangest powers of imagination. When fiction bleeds into fact, it destabilizes the boundary between what is possible and what is merely dreamed. If Clarke could so vividly describe a visiting cylinder in the 1970s, and then the universe produced an elongated interstellar traveler 4 decades later, what does that mean about the role of our imagination? Was it coincidence? Or do our stories serve as mirrors, shaping the way we perceive reality when it finally surprises us? There is something profoundly human about this interplay. Long before the telescope revealed the true nature of the stars, storytellers imagined gods, monsters, and angels inhabiting the sky. Myths filled the heavens with meaning, centuries before science revealed the physics of planets and galaxies. When Galileo first turned his glass toward Jupiter and saw its moons, he was not erasing those old stories. He was replacing them with new ones. Stories still rooted in wonder, but anchored by evidence. Science fiction continues this lineage. It is modern mythology, a way of dreaming not only about what lies beyond, but about how we might respond when the beyond comes close. In this way, Oumuamua's arrival was not only an astronomical event, but also a literary one. It invited us to recall Clarke's story, to notice how imagination had prepared us for awe. And awe, after all, is a double-edged feeling. It holds both beauty and terror. To stand before something unknown is to feel small, vulnerable, unprepared. Science fiction gives us a safe place to rehearse those feelings. We imagine alien probes, mysterious ships, strange encounters, and in that rehearsal, we learn how to think, how to feel, how to prepare for a reality we cannot yet grasp. Oumuamua forced us to confront the possibility that fiction is not always a distant dream. Sometimes it is a shadow cast ahead of reality, a way of glimpsing what may one day step into view. Clarke once wrote that any sufficiently advanced technology is indistinguishable from magic. In 2017, the reverse seemed true as well. Any sufficiently strange natural object could be indistinguishable from fiction. This blending of imagination and discovery does more than entertain. It challenges science itself. When astronomers invoked Clarke's Rama, they were not simply indulging in metaphor. They were acknowledging the limits of their categories, the possibility that something alien, whether technological or natural, had entered their field of view. It forced them to widen the conversation, to admit that imagination must sometimes walk alongside observation. And this raises a haunting question. If fiction prepared us for Oumuamua, what other stories are we rehearsing? What possibilities linger in our collective imagination, waiting for the universe to echo them back? Perhaps the tales we tell about interstellar travel, about encounters with other minds, about the quiet exchange of messages across the stars, are not just fantasies. Perhaps they are seeds, preparing us for futures we cannot yet see. To dwell on this is to recognize a delicate truth. Imagination is not the opposite of science. It is its companion. Where evidence ends, imagination begins, sketching the outlines of what might be. And when evidence finally catches up, we sometimes find that our sketches resemble the real thing, like a child's drawing that accidentally captures the essence of a face. Oumuamua was not Clarke's Rama. It was smaller, stranger, and it offered no hollow interior to explore. Yet its passing reminded us that fiction and reality dance more closely than we often admit. The universe is under no obligation to follow our stories, but sometimes it seems to rhyme with them. Take a moment to consider this. If the line between fiction and fact is thinner than we thought, then our dreams are not just idle fantasies. They are blueprints of possibility, rehearsals for futures we may one day encounter. Perhaps when we imagine alien probes or starships or visitors slipping into our solar system, we are not only entertaining ourselves. We are preparing for the day when the sky confirms our stories. And in that preparation lies a profound humility. For even as we dream of alien visitors, we must also be ready for the reminder that the universe itself can outdo our imaginations. Clarke's Rama was vast and deliberate. Oumuamua was small and fleeting, but in both, the feeling was the same. A brush with the unknown, a reminder that the cosmos is not ours alone. When science fiction bleeds into science fact, the line between imagination and discovery blurs. And maybe, just maybe, imagination has always been a rehearsal for truth. But not all theories look to aliens. Some return us to the raw beauty of nature itself. When an object defies easy explanation, the mind reaches for metaphor, for memory, for story. Some saw in Oumuamua the echo of science fiction, others the whisper of alien technology. But there was another possibility, one that did not invoke intelligence or design, but instead the raw, merciless hand of nature. Perhaps some astronomers suggested Oumuamua was not a craft at all, but a shard, a broken fragment of something once larger, once whole, now scattered across the galactic sea. To imagine this is to picture a tragedy written not in ink, but in stone and ice. Somewhere, long ago and far away, a planet circled its star in quiet routine. Perhaps it was rocky, perhaps icy, perhaps a body unlike anything in our solar system. Then something happened. A close encounter with a larger neighbor, a collision with a wandering giant, or the gravitational tides of its own star might have torn it apart. The pieces, once part of a world, were flung into space, some devoured, some drifting forever outward. Oumuamua, in this vision, was one such fragment, a splinter of a world that will never be whole again. The mechanics of such destruction are not rare. We see their echoes in our own backyard. The rings of Saturn are thought to be the remains of a shattered moon, pulled apart by tides so strong that stone became dust, and dust became the gleaming bands we admire through telescopes. Our asteroid belt, too, might once have been a planet that never quite formed, its material pulled and scattered by Jupiter's mighty gravity. Even comets, those icy travelers, often reveal scars of fragmentation, breaking into smaller pieces as they brush too close to the sun. If this happens here, in the relative safety of our solar system, why not elsewhere? Across billions of stars, countless worlds must have lived and died, built and broken. The galaxy may be strewn with the rubble of these events, fragments cast adrift, each carrying with it the fingerprints of its origin. Oumuamua might simply be one of these cosmic shards, wandering so long that it no longer resembles its parent, smoothed by eons of tumbling through interstellar night. And if this is true, then every fragment is like a message in a bottle. It carries within its composition the chemistry of the world it came from, the memory of its birth star, the violence of its destruction. To catch one is to hold, however briefly, a piece of a planet we will never see. Astronomers peering at Oumuamua through their instruments may not have known its exact parentage, but in its light curves, in its strange acceleration, in its refusal to fit neat categories, there may have been whispers of its story, a story written in a language we are only just learning to read. There is something poignant in this vision. A shard is, after all, a fragment of loss. To imagine Oumuamua as a broken piece is to imagine a world undone, a surface cracked, a landscape erased. And yet, from that destruction comes connection. The debris does not vanish into silence. It drifts outward, crossing gulfs of darkness, until one tiny fragment brushes our own neighborhood and reminds us of the fragile, ever-changing nature of worlds. This perspective also deepens our sense of kinship with the galaxy. If Oumuamua is a shard, then perhaps our own solar system has also sent out its fragments, pieces of comets and asteroids torn free by gravitational encounters and flung into interstellar space. Somewhere, circling another star, an astronomer may look up and notice a faint light, an unfamiliar traveler, and wonder about its origin. Perhaps it will be a shard of our own world, carrying with it the story of Earth, whispered in the faint spectrum of reflected sunlight. In this way, destruction becomes dialogue. The galaxy becomes a place where broken pieces speak across the stars, carrying the memory of their lost homes. But the vision of shards also unsettles. For if Oumuamua is a fragment, then it reminds us of the violence woven into the cosmos. Stars rip apart their planets, black holes tear matter into ribbons, collisions shatter moons, and even here on Earth, we live with the scars of ancient impacts. The universe is not gentle. Creation and destruction are bound together, inseparable. To hold a shard is to hold both loss and endurance, the persistence of matter after the fall of worlds. This duality, grief and wonder, fragility and resilience, echoes through our reflections on Oumuamua. Was it merely a piece of rubble, a wandering stone? Or was it more, a symbol of the interconnectedness of all things, proof that even brokenness can travel across light years and touch another world? Science and philosophy meet here. entwined in the mystery of a fragment that refuses to explain itself fully. And so we return to the humbling truth. Nature itself can conjure mysteries as strange as fiction, as evocative as any dream of alien design. To imagine Oumuamua as a shard is not to diminish its wonder. It is to recognize that the cosmos does not need intention to create astonishment. Randomness, violence, and time are enough to sculpt an object so odd, so improbable, that it challenges our categories and expands our imagination. Yet even here, even in the attempt to root Oumuamua in the raw beauty of nature, new mysteries unfold. For if it is a shard, why this shape? Why this acceleration? Why this particular combination of anomalies? Each natural explanation opens another question, another door into uncertainty. The fragment of a world is no less mysterious than the whisper of a craft. Both remind us that our understanding is provisional, fragile, incomplete. And perhaps this is the real message in the bottle. Not only the chemistry of a distant world, but the reminder that knowledge itself is always unfinished. Every shard we study, every anomaly we chase, is a clue, a fragment of a larger story we may never fully grasp. Oumuamua may be gone, slipping back into the dark, but its lesson lingers. The galaxy is not only alive with stars and planets, it is alive with fragments, each carrying a history, each inviting us to listen. Yet even nature's explanations often lead to new mysteries. Every riddle begins with a question, and for Oumuamua, perhaps the most haunting question of all was this: where did it come from? An object like this is not supposed to appear out of nowhere. It must have had a birthplace, a beginning, a moment when it was cast free from some ancient star system. To ask about its origin is to tug at a thread that unravels into the immensity of cosmic time. Astronomers, like detectives, tried to reconstruct the visitor's path. They traced its trajectory backward, winding through the invisible lines of gravity, past the planets and the sun, into the open sea of the galaxy. But the trail soon grew uncertain, blurred by the countless tugs and nudges it must have experienced over the ages. It did not come from any nearby star, no obvious source. Instead, the calculations suggested a stranger possibility, that Oumuamua may have wandered the galaxy for billions of years before brushing against our tiny corner of space. Think about that for a moment. Billions of years. Longer than Earth itself has existed. Longer than the oceans have washed our shores. Longer than life has stirred in the mud of primordial seas. If true, then this visitor was already drifting when our planet was still molten, when the moon was first torn from Earth's side, when the first stars of the Milky Way's current generation were being born. To encounter it is to reach back into prehistory so deep it almost dissolves into myth. Such an origin story transforms the way we see Oumuamua. It is not just a strange rock or shard, not just a fleeting anomaly. It is a survivor of time on a scale that humans can scarcely imagine. It has traveled across spiral arms, through interstellar clouds, past exploding stars. It may have skirted the shockwaves of supernovae, drifted through regions rich with dust and gas, endured radiation strong enough to strip the surfaces of worlds bare. And yet, it endured. The idea that it is older than Earth is both humbling and strangely intimate. To look at it, even faintly through telescopes, was to look at something that witnessed the galaxy long before our species, long before our world. It carried within its structure the marks of its journey, its surface darkened and reddened by cosmic rays, its shape perhaps sculpted by countless impacts or erosions. The galaxy itself was its sculptor, chiseling it slowly, invisibly, across unimaginable spans of time. This is the gift of deep time. It stretches imagination until it feels almost weightless, floating in the currents of ages. Humans count lives in decades, civilizations in millennia, but Oumuamua reminds us that the cosmos counts in billions, in epochs where entire continents rise and fall, where entire species bloom and vanish, all while a single shard continues its silent voyage. To meet such an object is to brush against the very fabric of eternity. And yet, the question of origin is not just poetic. It is scientific and unsettling. If Oumuamua came from another star system, then which one? Was it expelled during the birth of planets, flung outward like excess debris? Or was it hurled free by the collapse of a shattered world? Its velocity and direction offered clues, but none pointed cleanly to a single star. The galaxy is crowded, stars move, and over billions of years, the trails of memory are erased. Its birthplace may forever remain unknown. Still, astronomers speculated. Some pointed toward regions where stars form in clusters, dense with young suns and planetary material. These are places where gravitational encounters are common, where countless bodies are ejected into the void. Perhaps Oumuamua began there, just another casualty of celestial chaos. Others wondered if it had drifted even longer, older still, so old that its true star no longer shines, burned out in silence. In that case, Oumuamua is not only older than Earth, but older than many of the stars now circling the galaxy. Imagine the loneliness of such a journey. For billions of years, through cold and emptiness, it traveled without destination, without anchor, a solitary wanderer. And then, by chance, it entered our solar system, brushing past our sun almost unnoticed. For a few short months, we glimpsed it, studied it, puzzled over it. Then it was gone again, retreating back into the abyss. The encounter was brief, a crossing of paths between humanity and a traveler from a time before our beginning. To think of origin in this way also changes our sense of belonging. For if Oumuamua came from elsewhere, then so too do we. The atoms in our bodies, forged in ancient stars, have traveled even longer journeys. In some sense, we are all interstellar visitors, pieces of the galaxy gathered for a moment into human form. To meet Oumuamua was to meet kin, distant and alien, but kin nonetheless. It is a reminder that nothing in the universe is isolated, that everything flows, drifts, and mingles in the endless currents of time. But this line of thought leads to another question. If Oumuamua has wandered for billions of years, then surely it is not alone. Surely countless other fragments drift through the galaxy, unseen. Some must pass near stars, some even through planetary systems like ours. If we happen to notice this one, how many others have slipped by in silence, invisible to our instruments? And how many more will come, carrying with them stories older than our world? To ponder Oumuamua's origin is therefore to open the door to something larger. The possibility that our solar system is not a secluded island, but part of a flowing sea of interstellar debris. We are brushed, perhaps constantly, by the relics of ancient worlds, the remnants of distant systems, the whispers of events we will never witness. Each one is a letter from the galaxy, and only occasionally do we catch the envelope before it drifts away. And so, the question of origin is both a beginning and an ending. It cannot be answered fully, yet it invites us to imagine the galaxy not as a static stage, but as a dynamic ocean, carrying fragments endlessly across its waves. Oumuamua is a shard of that ocean's memory, a single note in a symphony that stretches across billions of years. And this makes us wonder, are we being visited more often than we realize? For every mystery that touches human awareness, countless others pass silently in the dark, unseen, unnoticed, their stories unrecorded. Oumuamua astonished us because we happened to look at the right patch of sky at the right time. But what about all the others? For if one visitor from the stars has slipped through, it follows that many more have likely done the same. The unsettling truth is that we may already have been visited 100 times over, and we never even knew. The limits of our vision are profound. Even today, with advanced telescopes and automated surveys scanning the heavens, we see only a fraction of the sky at any given moment. The universe is vast, and the windows through which we gaze are narrow. Before the 21st century, our ability to detect faint, fast-moving intruders was almost non-existent. A small object could streak past, brighter than most stars for just a few fleeting hours, and no one would notice. To put it more plainly, our awareness of the cosmos is like standing in a forest with a tiny lantern. The light circles around us, illuminating only a few nearby trees. Beyond that glow lies a vast wilderness, filled with life and movement, sounds and shadows, all hidden. The lantern feels sufficient, but in truth it shows us almost nothing. That is how we look at the universe. Our instruments, powerful though they seem, reveal only slivers of the whole. This raises a haunting possibility. What if Oumuamua was not the first interstellar visitor? What if it was only the first we happen to notice? Astronomers suspect that thousands of such objects may pass through the solar system each year. Most are small, dark, and quick, slipping in and out before our telescopes sweep across their path. The mathematics of probability suggests this This must be true. Our sun moves through the galaxy like a ship cutting through an endless ocean of debris. Inevitably, some of that debris will brush against us. But whether we notice depends entirely on the narrow keyhole of our vision. Consider how late we were in catching even large intruders from within our own solar system. In 1994, a comet named Shoemaker-Levy 9 slammed into Jupiter, exploding in the planet's atmosphere with the force of many nuclear bombs. The scars lasted for months, visible to anyone with a telescope. And yet, until just a year before impact, no one even knew the comet existed. If something so large, so dramatic, so close could escape notice until the final hour, how many small, swift interstellar wanderers must have slipped by unseen? The truth is humbling. For most of human history, the skies were silent, not because nothing passed above us, but because we lacked the tools to notice. Our ancestors gazed upward, crafting myths about the few wandering lights they could see, never suspecting that countless invisible visitors brushed past, just beyond their perception. Even now, with advanced surveys, the darkness still holds more than it reveals. There is also the question of scale. Oumuamua was perhaps 100 meters long, about the size of a skyscraper turned sideways. But what if others have been smaller? A fragment the size of a house or even a car could drift past without leaving the faintest trace in our records. And what if some were larger? Imagine a visitor the size of a mountain, darkened by cosmic radiation until it reflected almost no light. It could glide past Earth's orbit like a silent giant, unseen because it offered no bright reflection, no obvious signature. We would remain oblivious, blind in the shadow of a massive guest. The thought can be unsettling, even eerie. For if we cannot see these visitors, then how can we know how often they come, or what stories they carry, or what dangers they might pose? It reveals a humbling fact about our species. We live under an illusion of awareness, yet our sightline into the cosmos is painfully narrow. The truth is that we are small, fragile, and blind against the immensity of the night. But to call ourselves blind is not quite fair. We are, after all, newborns in the cosmic sense. The science of sky surveys is scarcely older than a few decades. Only with the rise of automated telescopes, wide-field cameras, and clever algorithms has our lantern begun to grow brighter. For most of history, we looked at the sky only occasionally, with eyes alone or small instruments. Now, for the first time, we are beginning to watch continuously, to scan systematically, to expand the circle of our light. And yet, knowing that countless visitors may already have passed us by, changes the story of Oumuamua. It shifts the narrative from uniqueness to abundance. Instead of a once-in-a-lifetime event, perhaps it was a reminder of an ongoing reality, one that has always been happening. The galaxy sends us visitors all the time, but we rarely notice. In this sense, Oumuamua was not a lone messenger, but the first whisper we managed to hear in a chorus that has been sounding for ages. To pause and reflect on this is to feel very small, but also very connected. The idea that we are constantly brushed by objects from other star systems makes the galaxy feel less distant. It suggests that the boundaries between solar systems are porous, that material is constantly exchanged, that the stars are not isolated but bound together in a slow, invisible dialogue of debris. Perhaps, without even realizing it, we live in the middle of an ongoing exchange of matter and memory, each passing shard a story carried across unimaginable distances. But there is also melancholy in this thought. To imagine all the visitors we never saw is to imagine all the stories we never read, all the letters we never opened. Each unseen shard could have taught us something, could have revealed the chemistry of a distant world, the geology of a forgotten planet, the secrets of a star system we will never reach. Each was an opportunity missed, a book that passed us by without ever being opened. And so, the idea of the unseen visitors does more than make us feel blind. It stirs longing, a longing to see more, to know more, to sharpen our eyes against the dark, to catch not just one messenger, but many, to build instruments so sensitive that no shard, however faint, can slip by unnoticed, to expand our lantern until it lights the entire forest of stars. The darkness, then, is not a permanent prison. It is a challenge, a call to stretch our vision, to lift our awareness, to push the boundaries of what is possible. For though the galaxy may be filled with visitors we never see, new technology promises to sharpen our cosmic vision. The age of blindness is ending. A new era of sight is just beginning. Every generation of stargazers has dreamed of seeing more, to pierce deeper into the darkness, to catch what has always slipped by unnoticed. For centuries, human eyes traced only the brightest wanderers across the night sky, their movements sketched onto parchment by patient hands. Telescopes extended that vision, revealing craters on the moons of Jupiter, the rings of Saturn. Cameras came next, recording what the eye could not, archiving faint glimmers for study. Computers joined, scanning images in ways no human ever could, teasing faint signatures out of the noise. Each step widened the circle of our lantern. Each step made the forest of the cosmos feel just a little less shadowed. But now, on the horizon, stands something altogether new. Something that promises to transform our blindness into something close to sight. The Vera C. Rubin Observatory, nestled high in the Chilean Andes, is not just another telescope. It is a new set of eyes for humanity, a sweeping gaze that will watch the entire sky with a kind of vigilance never before possible. The scale of its vision is almost unimaginable. Where most telescopes peer into narrow cones, like straws aimed at the heavens, Rubin will capture vast swaths of sky in a single glance. Night after night, it will scan the dome above, building an ever-changing map of the universe. It will not look at the stars once and then move on, but return again and again, catching anything that shifts, that blinks, that races across the field. The fleeting, the transient, the elusive. These are its quarry. For interstellar visitors, this is revolutionary. Oumuamua slipped into view almost by accident. Borisov, the second stranger, was found because one man happened to be scanning at the right time. But with Rubin, such accidents will become routine. Its detectors are so sensitive, its gaze so broad, that any sizable visitor brushing our system will be caught almost immediately. For the first time, humanity will have front-row seats to the drama of interstellar arrivals. Imagine the difference this makes. Instead of catching a visitor only as it is leaving, trailing into the darkness, we may spot one on the way in before it sweeps past the sun. Instead of a few hurried weeks of observation, we may have months, perhaps even years, to study it. Spacecraft could be prepared, missions launched, instruments aligned. We could chase the visitor, even intercept it, catching a shard of the galaxy not in passing, but in detail, up close, with cameras and sensors. What once seemed like luck will become opportunity. This shift is more than technological. It is philosophical. For the first time, we are no longer passive recipients of cosmic chance. We become active participants, ready to meet what comes, ready to witness what has always been hidden. The galaxy may be littered with messengers, and at last, we will not let them slip away unseen. But here is where the wonder deepens. Rubin will not only catch interstellar visitors, it will catch everything transient. Supernovae exploding in distant galaxies, asteroids tumbling past Earth, stars flickering with strange dimming patterns, even the faint signatures of worlds colliding. The universe is restless, filled with motion, filled with change. We have always known this in theory, but soon we will see it with our own eyes, unfolding night by night in a cascade of revelations. To reflect on this is to feel the weight of thresholds. Humanity has always lived with horizons, limits to vision and understanding. Each time those horizons expand, the world feels both larger and smaller at once. Larger because we realize how much more there is beyond us. Smaller because we realize how close it all feels, once hidden, now revealed. Rubin promises to do this again, to show us a universe alive with visitors and events, reminding us that we are not static beings in a static cosmos, but participants in an unfolding story. There is a gentle irony in this. For all our ambition to explore outward, to send probes and rockets, to imagine ships among the stars, the cosmos has always been coming to us. Visitors arrive unbidden, bringing with them hints of distant places, whispers of other worlds. Our task has simply been to notice. With Rubin, the act of noticing becomes almost inevitable. We will no longer miss the fleeting shadows, no longer let them slip through the gaps in our awareness. We will stand watch with eyes that do not blink, and the galaxy will reveal itself in ways it never has before. Yet with this gift comes a subtle unease. For if we are about to see more, then we are also about to learn truths that may unsettle us. Visitors may not always be gentle fragments or poetic shards. They could be large, dark, and dangerous, on trajectories that brush too close to Earth. They could carry mysteries we do not understand, anomalies we cannot explain. To sharpen our vision is to invite revelation. But revelation is not always comfortable. This is the paradox of sight. To open our eyes wider is to embrace wonder, but also vulnerability. We will learn not only how vast and alive the cosmos is, but also how fragile we are within it. The forest of the night may be more crowded than we ever suspected. Some visitors will be benign, drifting quietly past. Others may stir questions we cannot yet answer. And so, as we stand at the threshold of discovery, we must ask ourselves, should we be excited or should we be afraid? A visitor that enters the solar system without slowing down is more than just a puzzle of physics. It is also a story of emotion, a story of awe laced with unease. To look at Oumuamua was to marvel at the improbable, but beneath the marvel was a whisper of dread. Because when something approaches without invitation, moving in ways that defy our expectations, it stirs an ancient question in the human heart: friend or foe? Imagine a quiet village by the sea. The horizon has always been empty, the waves predictable, the shoreline familiar. Then one day, a dark silhouette appears against the light of dawn. A ship, unlike any ever seen, sails closer. It does not stop at the edge of the bay. It does not send signals or raise flags. It simply glides forward, silent, unreadable. The villagers gather on the shore, their hearts heavy with wonder, but also with fear. That is the story of Oumuamua, translated into the language of human memory. We are those villagers, and the cosmos is the sea. If Oumuamua was a natural shard of rock or ice, then it was harmless, a fragment of chance, drifting into our path and then away again. But if it was not, if its acceleration, its strange shape, its silent passage hinted at something engineered, then the metaphor of the village becomes harder to ignore. For what does one do when an unknown ship approaches? History offers troubling answers. Again and again, when civilizations have encountered one another, imbalance has followed. The stronger one writes the story, while the weaker one is often erased from it. The arrival of European ships on distant shores changed entire continents, often with devastating consequences for the people who had lived there for centuries. To imagine ourselves as the villagers is to feel the vulnerability of that moment. What if the ship on the horizon is not benign? What if it carries intentions we cannot predict? This fear is not irrational. It is a recognition of asymmetry. Humanity, for all its progress, is still young, fragile, limited to a single small world. If Oumuamua were artificial, if it were truly the work of another intelligence, then it represents a technology and a history vastly older and more advanced than our own. In such a meeting, we would not be the stronger voice. We would not even be the narrator. We would be the ones whose story could be rewritten in an instant. And yet, part of the dread lies in our own uncertainty. We do not know what it was, nor why it came. Perhaps it was not meant for us at all, merely drifting by, uninterested. But the lack of knowledge leaves a void, and human imagination fills that void with specters. The unknown is not empty. It is pregnant with every possibility, from wonder to annihilation. It is also worth remembering how small our defenses are. Earth is shielded, in some sense, by distance and obscurity. The galaxy is vast, and the odds of contact are slim. But should contact occur, should a vessel truly cross the boundary with intention, we would have little to offer in response. Our most advanced spacecraft crawl compared to the speeds required for interstellar travel. Our signals are faint. Our presence is still tentative. We are not ready for visitors, not truly. To imagine that Oumuamua might have been one is to look directly into the mirror of our own unpreparedness. This is why the fear lingers. It is not just about the object. It is about us, about our awareness of vulnerability, our fragility in the face of larger powers, our intuition that the universe is not a quiet garden, but a restless sea. When something enters our home without slowing down, without explanation, it is like a knock at the door in the middle of the night. You do not know who stands outside, and that uncertainty is its own kind of terror. And yet, fear is not the only response available to us. For woven into the same moment is something else, something gentler. Awe, wonder, curiosity. The villagers on the shore may tremble, but they also gaze with wide eyes, captivated by the sight of sails against the sky, by the promise of lands they never imagined. Fear asks what might be lost. Wonder asks what might be found. Both are valid. Both are human. To stand between these emotions is to feel the true weight of the unknown. It is both threat and possibility, both danger and invitation. To deny fear would be foolish, but to deny wonder would be impoverishing. Together, they create a tension, a balance, a reminder that discovery is never simple. And so, as we reflect on Oumuamua, we find ourselves suspended in this duality. It may have been a shard of rock, a fragment of natural beauty, and nothing more. Or it may have been something else, a messenger from intelligence far older than our own. We do not know. Perhaps we never will. But in that not knowing, we glimpse the truth of our place in the cosmos. Small, uncertain, but awake, capable of both trembling and dreaming. The unknown is frightening, yes, but it is also the place from which all meaning arises. To step into the dark is to risk, but also to discover. To meet the horizon with fear alone is to miss the full story. And perhaps, just perhaps, the next visitor will teach us that the unknown is not always to be feared, but sometimes to be welcomed. Yet fear is not the only response. There is also wonder. Oumuamua is more than a mystery of rock, ice, or possible engineering. It is, above all, a mirror held up against our small and temporary lives. To see something sweep across the solar system without hesitation, unbound by orbits, ignoring gravity's attempts to hold it, is to be reminded of scale, of proportion, of the fragile brevity of human existence. While we quarrel over borders etched onto maps, invisible lines no more permanent than a footprint in sand, here is a traveler that crosses gulfs beyond imagining. No line, no law, no argument can stop it. It comes, it passes, and it leaves, indifferent to the stories we tell about possession or control. Its movement is a quiet but overwhelming statement. The universe does not care for our divisions. The cosmos is whole, seamless, continuous, while we insist on fences that mean nothing beyond this small Earth. Imagine a grain of pollen drifting across a meadow in spring. It lands on one flower, then is lifted by the wind, carried far, perhaps to another field entirely. That is Oumuamua, drifting on the vast winds of the galaxy. Now imagine the ants below, bickering over tiny territories of soil, never once looking up, never realizing that something vast just passed above them, a piece of a world they will never know. In this metaphor, the ants are us. We live in the dirt of our concerns, but sometimes the sky places a reminder above us, something so strange that even we must pause our arguments and lift our heads. This is the humbling power of such a visitor. It does not only puzzle our telescopes or stir debates among scientists, it places our existence into context. Humanity is young, brief, and astonishingly small. Our lives, our wars, our inventions, even our dreams, are flickers against the background of cosmic time. Oumuamua had already been traveling for perhaps hundreds of millions of years before it brushed against our solar system. It may have begun its journey before the first mammals walked the Earth, before continents drifted into their present shapes, before even the planet itself was fully formed into the blue world we recognize. To encounter it, even for a moment, is to brush against the deep history of the galaxy, a history we are not central to. A history that does not wait for us and will not pause when we are gone. That realization is sobering, almost unbearable, but it is also liberating. For if we are small, then so are our fears. If we are temporary, then so are our conflicts. And if the universe is vast and open, then we are at least a part of it, woven into a story larger than any one species or world. Consider, too, the sheer scale of openness that Oumuamua represents. We sometimes imagine the solar system as a fortress, a bubble of planets circling their star, sealed from the outside. But the truth is more porous. Space is not a wall, but a sea, and we are not alone upon it. Fragments of other shores drift toward us, occasionally brushing our waters. The solar system is less an island and more a harbor, open to currents that carry messages from places we will never visit. To be reminded of this is to feel exposed, yes, but also connected. We are not cut off. We are part of a flow that stretches across the spiral arms of the galaxy. And what does this mean for us in practical terms? Perhaps very little. Oumuamua has passed. It gave us no signal, left us no gift, no threat. Its message, if it had one, was only its presence. But that presence alone speaks volumes. It whispers to us that the universe is restless, that objects move not in neat orbits, but in wandering arcs across stars. It tells us that our home is not isolated, but permeable. That realization shifts the ground beneath us. We are not living inside a locked chamber, but within an open corridor through which the universe can step at any time. There is humility in this, but also perspective. Humility because we are not in control. Perspective because this loss of control need not diminish us. Instead, it expands us. To look at Oumuamua is to realize that we are already participating in a story that stretches beyond Earth, beyond the sun, beyond anything we can draw on a chalkboard. It humbles us, yes, but in humbling us, it also enlarges us, reminding us that our existence has meaning not in ownership or permanence, but in awareness. Take a moment here to breathe and reflect on that. To be alive at this moment in history is to be part of the first generation that has looked up and noticed such a traveler. Countless humans lived and died without knowing that interstellar visitors passed through our sky. But you, here, now, know this. The awareness itself is a kind of gift. You are present for the first chapter of a much longer story. And perhaps, hidden inside this humility, is a lesson. If we are to survive, if we are to thrive, we must learn to see ourselves not as rulers of a small planet, but as participants in a vast web. Our borders do not matter to the stars. Our pride does not matter to interstellar fragments. Our conflicts, our possessions, even our fears are dust compared to the sweep of time that carries such objects across the galaxy. What matters is whether we can look up, whether we can see beyond ourselves, whether we can learn humility enough to listen when the universe sends a messenger, even a silent one. Oumuamua is gone, fading into the darkness between stars, a memory in our telescopes. But the humility it leaves behind remains. It is the same humility one feels standing at the edge of an ocean, watching waves that stretch beyond sight. It is the humility of mountains, of deserts, of night skies, where stars fall like rain. Humility is not weakness. It is recognition, awareness, perspective, and in that humility, something deeper stirs. A final question, quiet, almost whispered. If we are so small, if we are so temporary, then what truly is our place? What if these visitors are not accidents at all? What if they are not fragments of shattered worlds, nor comets lost in the wilderness of interstellar space? What if their arrivals are not random, but intentional, chosen, purposeful? To ask this is to shift the frame entirely, from chance to design, from coincidence to contact. Oumuamua was first described as a scout because its name in Hawaiian carried that meaning. A messenger, a herald, something that comes before. At first, this was taken as a poetic choice, a reflection of its role as the first confirmed interstellar object humanity had ever seen. But what if the name was closer to truth than anyone imagined? What if it really was a scout, not of chance, but of intention? When astronomers puzzled over its strange acceleration, its unusual shape, its refusal to behave like anything they had seen before, some entertained the thought that it might be artificial. Most dismissed it, at least publicly, because science prefers caution, because extraordinary claims require extraordinary evidence. And yet, quietly, the thought persists. Not proof, not certainty, but the haunting possibility that what passed through our solar system was not simply drifting. It was looking. It is not a stretch to imagine. Humanity itself has already planted its own messengers into the dark. The Voyager probes, each carrying a golden record, spin slowly in the endless night, already beyond the influence of the sun. They were not designed to slow down either. They were meant to move forever, small emissaries of our world, carrying whispers of who we are. We have also imagined sails, thin sheets of reflective material that use the push of light itself to cross the distances between stars. These are not fantasies, but beginnings, steps we have already taken. If we, with all our limitations, can dream this, then why not others? Why not someone older, more advanced, more patient? If Oumuamua was such a craft, then its silence becomes a kind of eloquence. Perhaps it did not need to signal. Perhaps its mission was not to announce, but to observe, to pass through quietly, unnoticed if possible, gathering what it could from afar. If we think of ourselves as the discoverers, the ones who spotted it, then the story feels like triumph. But what if the roles are reversed? What if we are not the discoverers, but the discovered? This idea has a way of flipping the balance of the narrative. We tell ourselves that we are explorers, the first steps toward contact. the curious species that looks outward while others remain quiet. But perhaps we are late to the story, not early. Perhaps the galaxy is already mapped, already traveled, already watched. We may not be the first to look outward. We may be the ones being looked upon. And what would that mean for us, if true? If our radio signals, leaking into space for a century, have already been heard? If our blue planet has already been cataloged, noted, filed away? The thought is humbling and unsettling because it moves us from the center of the stage to the margins. We are not the authors of discovery in this version. We are the subject of someone else's experiment, or perhaps just the object of their curiosity. It is worth remembering how unremarkable we might appear from a cosmic distance. To us, Earth is everything, the cradle of life, the seat of meaning. To another intelligence, older and broader in perspective, we might be nothing more than one green bead among billions, an ordinary world orbiting an ordinary star. To imagine being watched is not necessarily to imagine being valued. It may mean only that we are noted like a mark in a ledger, one entry among countless others. That too is a form of humility. But there is also wonder in this thought. For to be noticed at all is to be part of a greater whole. If we are being watched, then we are not alone. If we are observed, then our story is already part of a larger narrative. And perhaps, quietly, the watching is not hostile. Perhaps it is curiosity, the same kind of curiosity that drives us. Perhaps across the gulfs of light years, the impulse to know, to understand, to witness is universal. There is a haunting beauty in imagining an unseen gaze, passing over us like the shadow of a bird across the ground. We may never know if Oumuamua was natural or crafted, if it was random or deliberate. But to hold even the possibility that it was deliberate changes how we see ourselves. It makes us aware that discovery is not a one-way street. The universe is not a backdrop to our drama. We are also characters in a larger play, and others may already be watching from the wings. Take a moment here. Imagine standing beneath the night sky, the stars sharp and cold, and feeling not alone but observed, not threatened, not harmed, just noticed. Imagine that feeling, how it changes the quiet of the night. It adds a depth, a presence, as if the universe itself is awake. That, perhaps, is the final lesson of Oumuamua. It reminds us that the line between observer and observed is thin, and sometimes it blurs. We look outward, but perhaps outward is also looking inward. We search for signals, but perhaps we are already the signal. We imagine being discoverers, but perhaps, gently, we are already discovered. The story of an interstellar visitor is more than data points, more than orbital diagrams and spectral measurements. It is science, yes, but it is also poetry, a kind of quiet music played across unimaginable distances. When Oumuamua appeared, it did not arrive with trumpets or declarations. It arrived like a whisper, drifting through our solar system, then slipping away again, leaving behind not answers but questions, not certainty but wonder. To call it a shard of a broken world is to honor the violence and beauty of creation itself. If it was born from the ruins of a planet torn apart, then it carries within it the story of destruction and survival, a fragment of a history we will never witness. If it was an icy comet shedding nothing as it passed, then it is still remarkable, a ghost of distant stars, frozen and enduring across eons. And if, though unproven, it was engineered, a craft designed by hands or minds not our own, then its meaning is even greater, an artifact of another intelligence, a message written in motion rather than words. In every version, in every possibility, there is one truth that hums beneath the surface. The universe is alive with motion. Matter does not stay still. Stars are born, burn, and die. Planets collide, moons break apart, dust gathers and drifts. And from these endless exchanges, fragments escape into the vastness, carrying with them the signatures of their origins. Oumuamua was one such fragment, whether natural or not, whether simple or extraordinary. It reminds us that the galaxy is not silent. It breathes, it stirs, it sends its messengers without ceasing. To encounter it is to be reminded that we are not sealed in solitude. Our solar system is not a locked box, closed to the rest of creation. It is porous, open, connected. Streams of matter flow across the darkness, weaving invisible threads between distant suns. In this sense, we are not alone in our journey. Not necessarily in the presence of neighbors we can speak with, but in the larger sense of belonging to a story that is shared. Every atom of Oumuamua once belonged to another place, and yet here it came, passing through our skies. And every atom of us, too, was forged in stars that lived and died long before Earth was born. We are participants in the same grand circulation. Take a moment to feel that, to breathe slowly and imagine yourself not as an isolated being on a fragile planet, but as part of a cosmic current. The same current that carried Oumuamua through our system flows through you as well. The iron in your blood, the calcium in your bones, the oxygen filling your lungs, all of it came from stars that once scattered their remains into space. You too are a traveler, a vessel of borrowed stardust moving across the stream of time. And so, Oumuamua was not only a riddle for astronomers, it was a reminder of continuity. It whispered that our story is not just human, not just terrestrial, but cosmic. The universe speaks in fragments, in dust, in silent visitors that appear and vanish. Our role is not always to solve them completely, but to listen, to recognize the connection, to allow ourselves to be humbled by the immensity of it all. There is a tenderness in this perspective. To know that we are small is not despair, but intimacy. Smallness means we fit within something larger. Fragility means we are part of something alive, something that moves and changes. Ephemerality means our moments shine all the brighter, brief candles against the deep night. When Oumuamua slipped away, it did not leave us empty. It left us with a sense of belonging, of being written into the wider poetry of the cosmos. And perhaps that is the final meaning. We do not need to know for certain what it was. We do not need to capture it, dissect it, claim it. Its mystery is its gift. For mystery awakens the imagination, and imagination keeps us alive to possibility. The story of Oumuamua is not finished because it lives on in our thoughts, in our debates, in our dreams of what else may come. The universe does not shout, it whispers. In the drifting of objects, in the faint glow of distant stars, in the silence of the night sky. Oumuamua was one such whisper. A gentle reminder that we are not the only ones moving, that the cosmos is not empty, that we are part of a living, breathing whole. As we stand beneath the stars, waiting for the next visitor, we might hold on to this thought. The universe is speaking, always speaking, not in words, but in motion, in fragments, in the quiet arrival of travelers from afar. If we learn to listen, if we learn to pause and reflect, then we will hear it. And what we hear may not only teach us about the cosmos, it may teach us about ourselves. So let the story of Oumuamua be a lullaby of sorts, a reminder, soft and lingering, that we are connected, that we belong, that the night sky is never truly silent. And as you drift now towards sleep, remember this. Somewhere out there, in the deep and endless dark, another traveler may already be on its way, carrying another whisper across the sea of stars. A whisper meant not to frighten, but to remind that we are part of the story, that we are never truly alone, that the universe is watching gently, and that everything, even us, drifts together. Sleep well and dream of the stars.